Hello and welcome. In this section, I want to start to tackle two very important questions that we're going to be answering throughout this entire course. The two important questions are, what is Docker? And secondly, why do we use Docker? We're going to first tackle why we use Docker by going through a quick little demo right now. Now I'm going to show you a little flow diagram. This is a flow of probably a process you've gone through at least once in your life before. It's a flow of installing software on your personal computer. And I bet at least once for you, this is what has happened. Maybe you have downloaded some installer, you run that installer, and then inevitably at some point in time, you end up getting an error message during installation. So what do? Well, you probably troubleshoot the issue by looking on Google, you try to find a solution, you eventually solve that issue. You then rerun the installer, only to find, hey, ta-da, you have some other error appearing. And then you have to go through this entire troubleshooting process again. So this is, at its core, what Docker is trying to fix. Docker wants to make it really easy and really straightforward for you to install and run software on any given computer. Not just your computer, not just your personal laptop or your personal desktop, but on web servers as well, or any cloud-based computing platform. I want to give you a very quick demonstration of this flow right here in action, and then show you how quickly I can solve installing a problem, or installing a piece of software by making use of Docker. So I'm going to very quickly go through the flow of installing a piece of software called Redis. Redis is an in-memory data store. We're going to be using it quite a bit throughout this course. But for right now, I just want to give you a quick demo of how it can be a little bit challenging to get installed on your own computer. So I'm just going to go through the installation steps here very quickly. So this is the Redis homepage. This is the official download page. In theory, I could use the documentation here to install Redis on my local machine. I'm going to go down to the installation section. And it very proudly says, oh yeah, just run these 4 commands right here, and boom, that's pretty much it. You can then run Redis. So I'm going to grab the first command right here. I'm going to copy it, and then I'm going to run it inside my terminal. So I'll paste. There's the same exact command. I'm going to run it, and sure enough, yep, I get an error message. Now in this case, the error message is a little bit predictable. It's complaining about a program that is just not installed on my local machine. Now I could definitely go and troubleshoot this, install that program, and then try installing Redis again, but that's the whole point. You kind of get into this endless cycle of trying to do all this troubleshooting as you are installing and running software. So let me now show you how easy it is to run Redis if you are making use of Docker instead. I'm going to go back over to my command line, and I'm going to run one single command. I'll say docker run -it Redis, like so. I'll hit enter. And then after a very brief pause, almost instantaneously, I have an instance of Redis up and running on my computer. And that's pretty much it. That is Docker in a nutshell. That is how easy it is to run software when you're making use of Docker. So to answer the question very directly of why we use Docker, well, we make use of it because it makes life really easy for installing and running software without having to go through a whole bunch of setup or installation of dependencies. Now we're going to learn many more reasons throughout this course of why we use Docker, but I wanted to give you a very quick demo and show you how easy it can be to get up and running with some new piece of software when you are using Docker. Let's take a quick pause right here. We're going to come back to the next section and start trying to answer the question of what Docker is. So I'll see you in just a minute. In the last section, we tried to answer the question of why use Docker. And we eventually said that we use Docker because it makes it really easy to install and run new software on our computer. We're now going to try to answer the other big question here, which is, what is Docker? Well, this question is a lot more challenging to answer. Anytime you see someone refer to Docker in a blog post or an article or a forum or wherever it might be, they're kind of making reference to an entire ecosystem of different projects, tools, and pieces of software. So if someone says, oh yeah, I use Docker on my project, they might be referring to Docker Client or Docker Server. They might be referring to Docker Hub or Docker Compose. Again, these are all projects, tools, pieces of software that come together to form a platform or ecosystem around creating and running something called containers. And so your immediate question might be, okay, well, what's a container? That's a good question, and that's a question that we're going to be trying to answer throughout this entire course. Just a moment ago, when I ran that command at my terminal of docker run Redis, it went through a little series of actions behind the scenes. And we're going to examine that entire series of actions very closely over time. But for right now, let me give you two important pieces of terminology. When I ran that command, something called the Docker CLI reached out to something called the Docker Hub, and it downloaded a single file called an image. An image is a single file containing all the dependencies and all the configuration required to run a very specific program. For example, Redis, which is what the image that I just downloaded was supposed to run. This is a single file that gets stored on your hard drive. And at some point in time, you can use this image to create something called a container. A container is an instance of an image, and you can kind of think of it as being like a running program. We're going to go into great detail over time to learn exactly how a container works exactly, but for right now, all we really need to understand is that a container is a program with its own isolated set of hardware resources. So it kind of has its own little set or its own little space of memory, it has its own little space of networking technology, and its own little space of hard drive space as well. Okay, so I didn't really answer the question here of what Docker is, but we did learn at least that a reference to Docker is really talking about a whole collection of different projects and tools. And we also picked up two important pieces of terminology, a Docker image and a container. Now, these images and containers are the absolute backbone of what you and I are going to be working with throughout the rest of this course. So let's take a quick pause right now. We're going to come back to the next section, and we're going to start talking a little bit more about how we work with images and containers. So quick break, and I'll see you in just a minute. In the last section, we tried to answer the question, what is Docker? But we didn't really get a great explanation. We said, okay, it's a reference to a bunch of products. We then started to talk about something called an image and something called a container. At this point, we need to install some more software onto our machine so that you and I can work directly with images and containers so that we can get a better idea of how they work. So here's what you and I are going to do. We're going to be installing a piece of software called Docker for Windows or Docker for Mac, depending upon your operating system. Inside of this program are two very important tools that we're going to be making use of throughout this course. The first tool that's inside this package is something called the Docker client. The Docker client, also known as the Docker CLI, is a program that you and I are going to interact with quite a bit from our terminal. We're going to enter in commands to our terminal, issue them to Docker client. It's going to take our commands and figure out what to do with them. Now, the Docker client itself doesn't actually do anything with containers or images. Instead, the Docker client is really just a tool or a portal of sorts to help us interact with another piece of software that is included in this Docker for Windows or Mac package called the Docker server. This is also frequently called the Docker daemon. This program right here is the actual tool or the actual piece of software that is responsible for creating containers, images, maintaining containers, uploading images, and doing just about everything you can possibly imagine around the world of Docker. So it's the Docker client that you and I issue commands to. It's a thing that we interact with, and behind the scenes, this client is interacting with the Docker server. You and I are never going to really reach directly out to this Docker server. It's something that's just kind of running behind the scenes. So again, we're going to take a quick break right now. We're going to come back to the next section, and we're going to start installing this package so that we can get a better sense of how to work with images and containers. So quick break, and I'll see you in just a minute. In the last section, we started talking about using Docker for Windows or Docker for Mac to get access to the Docker client and the server. In this section, we're going to walk through the setup process on a Mac OS machine. So if you are using Windows right now, then pause this video and skip over to the next lecture. All right, so if you're still here, I'm going to assume that you are on a Mac OS based machine. So here's what we need to do. We're going to first go to docker.com inside of our browser, where we are going to sign up for a Docker Hub account. We need a Docker Hub account not only to download the Docker for Mac client, but we also need it for some stuff that we're going to do later on inside the course. After that, we're going to download the installer package. We're going to log into Docker, and then finally we're going to verify our installation by running one or two quick commands. So let's get to it. Again, the first thing we'll do is navigate to docker.com inside of our browser. So I'm going to go to docker.com, and then on the top right-hand side, you'll see a button that says Get Started. So I'm going to click on that. I'm then going to make sure that I am on the Developer tab, and then I'll find Download for Mac over here on the right-hand side. Now when I click on that button, it's going to take me to another page This is the page that we're going to ultimately download this program from, but you'll notice that before we download it, we have to actually sign up for an account and log into Docker. So I'm going to click on Please Log In to download right there. And then we get prompted with a login screen. Now, if you do not already have an account, you can find the Create Account button down here on the bottom right-hand side. So I'm going to open up that page very quickly. You'll notice that one of the first inputs that you have to enter on this sign up page is a Docker ID. This is a username of sorts, and it is going to be publicly visible to other people. We're going to need your Docker ID quite a bit throughout the remainder of this course, so no matter what you choose for your Docker ID right here, please make sure that it's something that you're going to remember. Okay, so once you sign up for your account, we will go ahead and log in and go back to this store page right here. So now that I'm signed in, I can see the Get Docker button right here. So I'm going to go ahead and click that, and that's going to start up the download. Now this is a rather large file, so just to save a little bit of time in this lecture, I went ahead and already downloaded the package. So once this thing has successfully downloaded on your machine, we're going to open it up. It's going to take just a second or two to do its little bit, of course. It always needs some extra time, right? And then once it's finally done, it's going to open up a window that looks like this right here. And so as you might guess, we're going to do a little drag and drop over to the Applications folder. Now, once you copy that thing over, we now have to start up Docker on your machine. You can do this by either opening up your Launchpad right here, and you can find the new Docker program listed, or inside of any Folder Explorer window, you can go to the Applications section over here and find the listing for Docker. Now, once you get this thing copied over and installed, we're going to launch Docker by double-clicking it. The first time you do this, it's going to appear that nothing at all is happening. But if you look up at the top right-hand side of your screen, you'll see this little kind of whale icon with a set of boxes on it. And if you click on that, you'll see something that says Docker is starting. All right, after a minute or two, it's going to eventually resolve, and the boxes are going to go completely steady. And that means that everything is done and set up on your local machine. Again, it might take a minute or two, so give it a little bit of time to get through all of its little steps. All right, now you'll notice that my little boxes have steadied out, which means that Docker has successfully booted up. So now the last thing that we're going to do is make sure that we log into Docker. So you're going to click on this little button, and then you're going to see a button right here or so that says Login with Docker. When you click on that, it's going to pop open a little window where you're going to enter in your Docker ID. Remember, that's the username, not your email. So it's the Docker ID and your password. Now, once you do that, the very last thing that we need to do is we need to make sure that we can verify that everything was set up correctly. And so for this, you're going to open up your terminal. You can open up your terminal in any folder, doesn't matter, and we're going to run a single command, docker version, like so. As long as you see something like this appear on the screen, that means that you are all set and you're good to go. If you don't see something like this, if you get an error message, it means that something went wrong with the installation process. And you'll want to hop over to the Q&A section attached to this lecture, where we'll do a little bit of troubleshooting. All right, so that's it. Let's take a quick pause right here, and we'll continue in the next section.
In this section, we're going to walk through the setup and installation of Docker on a Windows-based machine. We're going to first get started by opening up our browser and navigating to docker.com. Once you're here, you're going to find the Get Started button on the top right-hand side. We'll click it, and then we can scroll down a little bit and find the link that'll take us to Docker for Windows. Then once we're over here, you'll notice that the blue download button on the top right-hand side requires you to actually log in with a Docker account before you can actually download the software. Now, I know that it is a pain to have to sign up for something before you can download any software, but in this case, it's kind of doing us a favor because we definitely are going to ultimately need a Docker account to do a lot of the things that we want to do inside this course. So I'm going to click on that Login to Download button. And then if you do not have an account already with Docker, you can click on the Create Account button down here. Now, as a quick note, when you first create your Docker account, you're going to be prompted for a Docker ID. This is like a username of sorts, and so it could be any username type word that you want it to be. I do have to ask you to make sure that you keep your Docker ID around and do not forget it, because we're going to make use of it pretty soon. All right, so once you create your account, you can go ahead and sign in, and then we'll click on the blue Get Docker link right here. and that's going to download the executable file with Docker. Now I've gone ahead and already downloaded this thing just to save us a little bit of time. So once you download that executable and start it up, you're going to see a window like this. Now we want to make sure that we are not using Windows-based containers. We want to use Linux containers. So we're not going to check the box right here. After that, I'll hit OK. It's going to go through a little bit of setup. This is going to take a minute or two, so I'm just going to let it sit. We'll take a quick pause, and we'll come back together in the next section. In the last section, we started installing Docker on a Windows-based machine. After that installer finishes, it's going to prompt you to log out and log back in. So you can click the button inside the installer that will automatically log you out. When you log back into your machine, you're going to see a new icon on the desktop that says Docker for Windows. You can double-click that executable, and then you're going to very quickly see a message pop up that says that your computer has to automatically restart. So as you might guess, we don't have a lot of decision here, and so we're going to hit OK to allow our machine to automatically restart. So we're going to take another quick pause right now, and I'll catch you again in just a minute. In the last section, we restarted our computer after successfully installing Docker for Windows. I'm now going to double-click on this icon again, and then after a second or two, you can open up your taskbar on the very bottom right-hand side of your screen, and you're going to see a little Docker is running icon appear right here. Docker is going to take 1 or 2 minutes to start up, and then it's going to eventually pop open a little window that looks like this right here, and you might see the same exact thing as a little pop-up on the bottom right-hand side. So we're going to sign in with our Docker ID and our password. Once you do that, you'll then be able to start up your terminal, and inside of your terminal, run the command docker version, like so. When you run that command, you should see a little bit of info like this appear on the screen. I know this text is very small. Just so you know, I do not normally record on a Windows-based machine, so I know that this text right here is a little bit small. As long as you can run Docker version and see some text like this appear, that means you are good to go and you're ready to continue into the next section. So let's take a pause right here, and I'll catch you in just a minute.
In the last section, we downloaded and installed Docker for Windows or Docker for Mac on your personal computer. You should now be able to run the command docker version at the command line and see a little bit of text like this appear. I now want to write out our very first kind of meaningful command with the Docker client or the Docker CLI. We're going to run a very quick command here, and then we're going to go through a very specific flow of actions that occurred when that command got executed. So here's the command. We're going to write docker run hello-world. Yes, it is kind of a hello world thing of sorts. Don't worry, it's going to be rather interesting. I'll then press enter, and we're going to very quickly see a lot of text start to scroll along the screen. Now I'm going to scroll up a little bit, and you'll see a little hello from Docker message right here. And then you'll notice underneath that, it lists out the series of steps that just occurred when you ran that command. Now we're going to go over the series of steps right here in great detail, so if you want to, you can kind of ignore that text for right now. I'm going to scroll up a little bit further, and I want you to see up here, it says unable to find image hello world locally. All right, so with that in mind, let's go take a look at a couple of diagrams that are going to help explain what just occurred when we ran that command. All right, here we go. So at the terminal, you and I executed the command docker run hello world. That starts up the Docker client or the Docker CLI. Again, the Docker CLI is in charge of taking commands from you, kind of doing a little bit of processing on them, and then communicating the commands over to something called the Docker server. And it's that Docker server that is really in charge of the heavy lifting. When we ran the command docker run hello world, that meant that we wanted to start up a new container using the image with the name of hello world. The hello world image has a tiny little program inside of it whose sole purpose, sole job, is to print out the message that you see right here. That's the only purpose of that image. Now, when we ran that command and it was issued over to the Docker server, a series of actions very quickly occurred in the background. The Docker server saw that we were trying to start up a new container using an image called hello world. The first thing that the Docker server did was check to see if it already had a local copy, like a copy on your personal machine, of the hello world image or that hello world file. So the Docker server looked into something called the image cache. Now, because you and I just installed Docker on our personal computers, the image cache is currently empty. we have no images that have already been downloaded before. So because the image cache was empty, the Docker server decided to reach out to a free service called Docker Hub. The Docker Hub is a repository of free public images that you can freely download and run on your personal computer. So Docker server reached out to Docker Hub and said, hey, I'm looking for an image called Hello World. Do you have one? Of course, the Docker Hub does. So Docker server downloaded this Hello World file and stored it on your personal computer in this image cache, where it can now be reran at some point in the future very quickly without having to re-download it from the Docker Hub. So essentially, we downloaded it over here like so. After that, the Docker server then said, okay, great, I've got this image, and now it's time to use it to create an instance of a container. And remember what we just said about a container a moment ago. An instant container is an instance of an image. Its sole purpose is to run one very specific program. So the Docker server then essentially took that single file, loaded it up into memory, created a container out of it, and then ran a single program inside of it. And that single program's purpose was to print out the message that you see right here. So that's pretty much it. That's what happens when you run this docker run command. It reaches out to Docker Hub, it grabs the image, and then it creates a container out of that image. Now, one thing that you'll notice that's kind of interesting, if we run the docker run hello world command a second time, you'll notice that we are not going to see the message of downloading or container image not found locally that we saw the first time. So scroll back up to the very top. Here's the first time that we ran the command. You'll notice that up here it said unable to find image locally, but now the second time we did not see that message. And that is because we already downloaded it to our image cache on our personal computer. So the big lesson here is that the first time that you try to make use of any of these public images over here, you're going to have to do a little bit of a download, but then in the future after that, you can start up a container using that image much more quickly because the image has already been downloaded to your computer. All right. Now, in this entire flow, one thing that we've been kind of light on at this point is talking about exactly what a container is. So let's take a quick pause right here. We're going to come back in the next section and go into a little bit greater detail on exactly what a container is. So quick break, and I'll see you in just a minute. In the last section, we continued to talk a little bit about images, but we're still surprisingly light on some of the details around exactly what a container is. So in this section, I'm going to give you a behind-the-scenes look at what a container is and how it is created on your machine. Now, to understand a container, you first need to have a little bit of background on exactly how your operating system runs on your computer. So I'm going to first give you a quick overview of your operating system. Okay, so this is a quick overview of the operating system on your computer. Most operating systems have something called a kernel. This kernel is a running software process that governs access between all the programs that are running on your computer and all the physical hardware that is connected to your computer as well. So up here at the top of this diagram, we have different programs that your computer is running, such as Chrome or Terminal, Spotify, or Node.js. If you've ever made use of Node.js before and you've written a file to the hard drive, it's technically not Node.js that is speaking directly to the physical device. Instead, Node.js says to your kernel, hey, I want to write a file to the hard drive. The kernel then takes that information and eventually persists it to the hard disk. So the kernel is always kind of this intermediate layer that governs access between these programs and your actual hard drive. The other important thing to understand here is that these running programs interact with the kernel through things called system calls. These are essentially like function invocations. The kernel exposes different endpoints to say, hey, if you want to write a file to the hard drive, call this endpoint or this function right here. It takes some amount of information, and then that information will be eventually written to the hard disk or memory or whatever else is required. Now, thinking about this entire system right here, I want to pose a kind of hypothetical situation to you. I want you to imagine for just a second that you and I have two programs running on our computer. Maybe one of them is Chrome, like Chrome the web browser, and the other is Node.js, the JavaScript server-side runtime. I want you to imagine that we're in a crazy world where Chrome, in order to work properly, has to have Python version 2 installed, and Node.js has to have version 3 installed. However, on our hard disk, we only have access to Python version 2, and for whatever crazy reason, we are not allowed to have two identical installations of Python at the same time. So as it stands right now, Chrome would work properly because it has access to version 2, but Node.js would not because we do not have a version or a copy of Python version 3. Again, this is a completely make-believe situation. I just want you to kind of consider this for a second, because this is kind of leading into what a container is. So how could we solve this issue? Well, one way to do it would be to make use of an operating system feature known as namespacing. With namespacing, we can look at all of the different hardware resources connected to our computer, and we can essentially segment out portions of those resources. So we could create a segment of our hard disk specifically dedicated to housing Python version 2. And we could make a second segment specifically dedicated to housing Python version 3. Then, to make sure that Chrome has access to this segment over here and Node.js has access to this segment over here, anytime that either of them issues a system call to read information off the hard drive, the kernel will look at that incoming system call and try to figure out which process it is coming from. So the kernel could say, okay, if Chrome is trying to read some information off the hard drive, I'm going to direct that call over to this little segment of the hard disk over here, the segment that has Python version 2. And Node.js, anytime that makes a system call to read the hard drive, the kernel can redirect that over to this segment for Python version 3. And so by making use of this kind of namespacing or segmenting feature, we can have the ability to make sure that Chrome and Node.js are able to work on the same machine. Now, again, in reality, neither of these actually need an installation of Python. This is just a quick example. So this entire process of kind of segmenting a hardware resource based on the process that is asking for it is known as namespacing. With namespacing, we are allowed to isolate resources per a process or a group of processes. And we're essentially saying that anytime this particular process asks for a resource, we're going to direct it to this one little specific area of the given piece of hardware. Now, namespacing is not only used for hardware, it can be also used for software elements as well. So for example, we can namespace a process to restrict the area of a hard drive that is available, or the network devices that are available, or the ability to talk to other processes, or the ability to see other processes. These are all things that we can use namespacing for to essentially limit the resources or kind of redirect requests for resource from a particular process. Very closely related to this idea of namespacing is another feature called control groups. A control group can be used to limit the amount of resources that a particular process can use. So namespacing is for saying, hey, this area of the hard drive is for this process. A control group can be used to limit the amount of memory that a process can use, the amount of CPU, the amount of hard drive input-output, and the amount of network bandwidth as well. So these two features put together can be used to really kind of isolate a single process and limit the amount of resources it can talk to and the amount of bandwidth, essentially, that it can make use of. Now, as you might imagine, this entire kind of little section right here, this entire vertical of a running process plus this little segment of a resource that it can talk to is what we refer to as a container. And so when people say, oh yeah, I have a Docker container, you really should not think of these as being like a physical construct that exists inside of your computer. Instead, a container is really a process or a set of processes that have a grouping of resources specifically assigned to it. And so this is a diagram that we're going to be looking at quite a bit anytime that we think about a container. We've got some running process that sends a system call to a kernel. The kernel is going to look at that incoming system call and direct it to a very specific portion of the hard drive, the RAM, CPU, or whatever else it might need. And a portion of each of these resources is made available to that singular process. Now, the last question you might have here is, okay, well, I get what a container is, but with that in mind, what is the real relation between one of those containers, or that kind of singular process and grouping of resources, to an image? How does that single file eventually create this container? Well, that's a good question. One more quick diagram. Anytime that we talk about an image, we're really talking about a file system snapshot. So this is essentially kind of like a copy-paste of a very specific set of directories or files. And so we might have an image that contains just Chrome and Python. An image will also contain a specific startup command. So here's what happens behind the scenes when we take an image and turn it into a container. First off, the kernel is going to isolate a little section of the hard drive and make it available to just this container. And so we can kind of imagine that after that little subset is created, the file snapshot inside the image is taken and placed into that little segment of the hard drive. And so now inside of this very specific grouping of resources, we've got a little section of the hard drive that has just Chrome and Python installed, and essentially nothing else. The startup command is then executed, which we can kind of imagine this case is like startup Chrome, just run Chrome for me. And so Chrome is invoked, we create a new instance of that process, and that created process is then isolated to this set of resources inside the container. So that's pretty much it. That is the relationship between a container and an image, and it's how an image is eventually taken and turned into a running container. Now there's still a tremendous amount more to learn about containers and images, so let's take a quick break and continue in the next section. In the last section, we had a long discussion about the relationship between a container and an image. We had said that a container is a running process along with a subset of physical resources on your computer that are allocated to that process specifically. We also spoke a little bit about the relationship between an image and a running container. Remember, an image is really kind of a snapshot of the file system along with a very specific startup command as well. Now, one thing that I want to mention very quickly here, in the last section, we spoke a little bit about the separation or the kind of the isolation of these resources through a technique called namespacing. And we also said that we could limit the amount of resources used by these control group things as well. Now, this feature of namespacing and control groups is not included by default with all operating systems, even though in the last section I had kind of specifically said like, oh yeah, your operating system has a kernel too. These features of namespacing and control groups are specific to the Linux operating system. So namespacing, control groups belong to Linux, not to Windows, not to Mac OS. So that might make you kind of question or wonder, how are you running Docker right now? You know, we are running a Docker client and we are running Docker containers on a Mac OS or a Windows operating system. How is that happening if these are Linux specific features? Well, here's what's happening behind the scenes. When you installed Docker for Windows or Docker for Mac just a moment ago in the last couple of sections, you installed a Linux virtual machine. So long as Docker up here is running, you technically have a Linux virtual machine running on your computer. Inside of this virtual machine is where all of these containers are going to be created. So inside the virtual machine, we have a Linux kernel, and that Linux kernel is going to be hosting running processes inside of containers. And it's that Linux kernel that's going to be in charge of limiting access or kind of constraining access or isolating access to different hardware resources on your computer. You can actually kind of see this Linux virtual machine in practice by opening up your terminal right now. And if you run that Docker version command again and look at your server, you'll notice that there's actually an OS entry on here. And you'll notice that it probably doesn't have your operating system listed. Mine, for example, right here says very specifically Linux as the operating system. So that is kind of specifying that I'm running a Linux virtual machine, and that's what's being used to host all these different containers that you and I are going to be working with. So just a little bit of interesting trivia. Now let's take another quick break right here. We're going to continue the next section and start digging into the Docker client a little bit more. So quick break, and I'll see you in just a minute.